Okay, so today we're going to look at discrete random variables. Learning intentions for today is to be able to identify discrete data, know what discrete random variable is, and be able to construct probability distribution tables and do calculations with them. Okay, so we have two kinds of data, discrete and continuous. Discrete values take on specific values like 0, 1, 2, 3, 4, 5. They don't have to be whole numbers, but they usually are, and they're usually things that you can count. That's the rule of thumb for discrete values, such as number of children in a family. You have 0, 1, 2, or 3 kids in a family, but you don't have 3.5 kids in your family. Okay, continuous data usually takes on any value in an interval, and the rule of thumb there is if you're measuring it, it's continuous, and that's usually things like height or weight or other stuff that you might measure. Okay, so now we're going to talk about discrete random variables. So we're going to consider a coin being flipped 3 times. I have a tree diagram there and a sample space written out for us. And what we're going to do is we're going to simplify that sample space by using numbers. So we're going to let x equal the number of heads. Okay, so we have x equals 3, x equals 2, x equals 1, and x equals none. And so x is the number of heads we can have. We can see that x can take on the values 0, 1, 2, or 3. And so we've simplified our sample space from the list above, this list here, into just the numbers 0, 1, 2, and 3. And we've lost a little bit of information when we've done that, but we now have something that's perhaps easier to work with. And so we can put those outcomes into a probability distribution table and work out the probability of each of those things happening. So probability of getting a 0, having x equal to 0, so no heads, there is just one way to do that out of 8 possibilities. So that's a probability of 1 on 8. Probability of getting a 1, there are 3 ways to have that happen. So that's 3 on 8. Getting a 2 is also 3 on 8. And getting a 3 is 1 on 8. And so it's important to note that each of those events has a different probability, so they're not all the same likelihood of outcome, whereas in our initial sample space there, they all had the same likelihood of outcome. They all had the same probability. Okay, and there's a couple of points here. So first one, we note that all the probabilities are between 0 and 1. We know that about probability. And the second one is if we add all of those together, we should get 1. Because they are all the possibilities. And they do, so that works out. Okay, probability of x equaling 1, so that's just getting 1 head. We can just look that up in our table. That's 3/8. And probability of x being less than 2. So less than 2 or equal to 2. So that is that one, and that one. And so we can just add all of those together. Now you might also notice that that is going to be the same as 1 minus the probability of getting the 3. Okay, and so that x is our discrete random variable. It's discrete because it's discrete data, and it's a variable because it can take on different values. But not just any different value, any old value, it's got to take on values out of its sample space. Okay, so probability of x being equal to little x, that can also just be written as p of x. Alright, that means the same thing. So p of x means the probability that the variable will take on the variable x. Okay. So this is actually a function now. We've got function notation with an input, and that's the discrete probability function or a probability mass function. And again, we can see that the probabilities or the outputs of p of x have to add up to 1, so that's probabilities have to add up to 1. And we can also graph p of x, and note that it is a discrete graph, so we have discrete data points. There's no line joining those together. Okay, so we have a worked example here. Please read the question. Okay, we're going to work out the probability x greater than 4, greater than or equal to 4. So that means we just add up all the values of x greater than or equal to 4. Okay, and there it is. So we get 0.74. Okay, now we have a conditional probability question. So we have x greater than or equal to 4 given that it's already greater than 2. So that is the probability that x is greater than or equal to 2. So we have reduced sample space, so our denominator, that will be our denominator, will be that, all of those added up, and our numerator is going to be x greater than or equal to 4. Okay, and so more formally, we can write that up using our rule. We have the intersection of x greater than or equal to 4 with x greater than 2. So that's the purple bit, and the red bit is the denominator. Okay, there we go, 74/99. Okay, so now we have less than 5 given that it's greater than 2. So greater than 2, that, oh, hang on, I'll use red again. Greater than 2 is still our denominator, and less than 5, that's less than 5. And for our numerator, we only want the intersection. Okay, so that means we have the intersection of less than 5 and greater than 2. And that is where x equals 3 and x equals 4. So we add those together, we get 0.65 over 99. And that is 65/99. Okay, so exam question. Here's exam 1, no calculators. We have discrete random variable x with a probability distribution. Find the value of p. Alright, first thing to note is that's negative, which is weird, but that's allowed, that's fine. Okay. So what are we going to do? We know that all the probabilities have to sum to 1. Equals 1, sum to 1. And now we just have a quadratic to solve. So methods loves a quadratic. I'm going to multiply through both sides by 8. So I get 16p squared plus 2p plus 4p plus 1 equals 8. That's multiplying both sides by 8. I get 16p squared plus 6p. Subtract 8 from both sides. Gives me -7. Okay, that's pretty gross, but we need to factorize it and solve that. So my value for AC is 7 times 16, that's 70, plus 7, 6 is 42, that's 112, so that's my value for AC, 112, and so I need factors of AC that will add to 6. Factor bucket for 112 is going to be 56 and 2. And now I'm going to have 56 again, so that is 28 and halve and double. So 28 and 4, 14 and 8. 14 and 8 actually gets me there, so I don't need to do any more. So I need a positive 6, so that is positive 14 and negative 8. Split the middle term. Uh, 8p is a common factor. And so I have 2p minus 1, 8p plus 7. P equals a half. Or P equals negative 7 on 8. And let's see, P equals negative 7 on 8 would give me a negative value when x equals 1, and that's not allowed. I can't have negative values of probability, so reject. P equals negative 7 on 8.